All right, folks, finally it's page 6. Let's go ahead and get through this. Now we're going to actually go back and talk a little bit about experimental design. In this case, we're looking at testing with distractions. Suppose you're designing an experiment to determine if students perform better on tests when there are no distractions, such as like a teacher talking on a phone. And you know that happens in my class all the time. I randomly, while students are testing, I pick up the phone and just give my buddies a call. Anyway, so let's say we have access to 2 classrooms, 30 volunteers are willing to participate in this experiment. Part A of the problem says design an experiment so that a 2-sample t-test would be the appropriate inference procedure. So let's go ahead and kind of outline what this experiment would look like. Experimental design was back in chapter 4, so you're going to have to kind of go in the Wayback Machine to remember some of this, but we're going to start by saying we've got 30 subjects. We're going to randomize them somehow, and we're going to take half of them up here to treatment A with a distraction. The other half get treatment B, which is no distraction. Then we're going to give them some kind of a test. And we're going to score it, and we'll call this X bar sub A, the mean score for the group that got treatment A, and X bar sub B for the mean score for the group that got treatment B. And then we're going to come down here and do some comparison. Now, back in chapter 4, when we got to this point, we would just say something like compare results. But we're going to be a little more specific now. And we're going to say, hey, we got a test for this. It's a 2-sample t-test. And we'll go ahead and compare mu A minus mu B. And that would be what we expect the population score for subjects similar to, for the population similar to those subjects we have in the test for the group with the distraction, that mean, minus the group without. Okay, so now I'm going to go ahead and just write out an explanation for that experiment. We know that a diagram is not sufficient. We actually have to write it out. So here's what I would say. And that's it, folks. Pretty self-explanatory. The thing I want to highlight there is what our actual hypotheses are for this test. The null hypothesis is that there is no difference between the two groups. The means should be equal. Versus the alternative that says if we take the distracted group and we subtract from that the not distracted group, then that should be less than 0. And that means that we're anticipating the distractions cause lower test scores. Okay, let's now move on to part B, where we're asked to design a slightly different experiment. Part B says design an experiment so that a paired t-test would be the appropriate inference procedure. In this case, a paired t-test means we're going to do a matched pairs design. The outline for this experiment is going to look like this. So group A, first we have the 30 subjects. We're going to split them in half randomly. And group A is going to have a distraction and then a test. And then we are going to give them a similar but different test where they get no distraction and then the test. So group B will do the opposite. So at the end of this experiment, what are we going to do? This time we don't have a 2-sample test we're going to do because basically both groups did the same thing. We just did it in a different order. So what we're going to do now is a 1-sample t-test for the mean difference. That's a lowercase d, which is my subscript, and I'll define that here in a little bit. Remember, a 1-sample t-test, that's back in chapter 8. Now check that. chapter 9. So that is actually not from this chapter. But I'm going to go ahead and describe now. So there's the outline of my experiment. Now I'm going to provide you a written description of it. All right, folks, that's a long description of this test, but very thorough. First of all, here we've got the definition of this measurement, delta, the distraction score minus the no distraction score. And then when we perform a one sample t-test for significance of the true mean delta and test scores, we have these two hypotheses. The null is that the mean delta is 0, meaning there's no difference, versus the alternative where that delta is less than 0 because we are subtracting the no distraction score from the distraction score. Last thing we got to do here to wrap up this marathon lesson is decide which experimental design is better, and that answer is simple. All right, folks, that's it. Matched pairs design is better because each subject serves as his or her own control, accounting for differences in individual student ability. Because if by chance all the really, really smart students got put into the group with no distraction, that might skew our results one way or the other. Okay, last thing I want to remind you here is a little principle of experimental design. And this is something we talked about way back in chapter 4. Remember, control what you can, block what you can't, and randomize the rest. Congrats, you made it through section 10.2.